This is lesson 6 from the using units of measurement topic, and this one is solve length and area problems. The learning goal for this one is to look into the areas of rectangles and triangles and how their formulas are used. The success criteria for this one is to solve problems involving the comparison of lengths and areas using appropriate units. Now there's a bit to digest, unpack and digest with this topic because there's a few formulas, namely 2 formulas that I want to show you, but more so I want to look into the concept of how area works and compare different area sizes based on the weird type of shapes that you can get. And this is the first example here. So this first example says which shape has the largest area, and what this is asking for is out of these 4 shapes, which one entails the most squares within the middle. So obviously there are different approaches to this. You can literally count each square one by one in order to try to find the total amount, or you can use what's called formulas, and these formulas can help us determine a shortcut method of finding how many squares there are. Now what I mean by formulas is with a rectangle, the formula for the area is just getting whatever the length is, which I'll put as L, and multiplying it whatever the width is, which I'll put as W. So for a rectangle, the area is length times width. Now we can do this for shape 1 and shape 4. Shape 2 and shape 3, we do use this formula in conjunction with another one, but we'll get to that in a second. So we know that shape 1 is 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7, 8. This is 4 by 8, which is 32, whatever unit it is, squared. So there are 32 squares within this. Okay, so we can just write 32. And with 4, this is a 2 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So this is 2 by 17, which is 34. Now, with shape 2 and 3, we've got these triangles that are attached to already what's called a composite shape. So if I were to break this up here and here, so we can see that there's a triangle here, a rectangle here, and a rectangle here. Now, to get the area of a triangle, and there are different ways of writing this formula, I'm going to write it the way that I like writing it. It is half times base times height. So it kind of looks familiar to the rectangle. Obviously we're using different letters, but we have a letter times a letter. We've got this letter times a letter here, base times height, but we've got this half times that's tagging along. That just means that whatever we get as our base times height, we just times it by half or divide it by 2. It's the same thing. And that's because a triangle, any type of triangle that you draw, is always half the shape of a rectangle or half the shape of a square. And there's a proof behind this, but we're not going to look into it right now. All we want to know is, okay, what's our base for this little triangle here? It's 1, 1, 2, 3, 4. So 1 times 4 is 4, and half of 4 is 2. So this little area in here is 2. This is a 2 by 2. 2 times 2 is 4, and half of 4 is 2. So this little formula in here is 2. We've got if we're using this as our split line, we've got a 1, 2, 3, 4, 5, 6, 7, 7 by 2, which is 14. So the 14 squares here. And 1, 2, 3, 4, 5, 6, 6 by 2, which is a 12. Now that we've got the areas of these internal shapes, we can just add this up. 12 plus 14 is 26, plus another 2 is 28, plus another 2 is 30. So the area for this composite shape is 30. And so far it's looking like this shape 4 is the biggest one. We've got one more here. Again, we can break this up into this triangle here and this triangle here. So this is a 1 by 2. So 2 times 1 is 2, and then half of that is 1. So this area within this little this triangle is 1. This is a 2 by 2, which is 4. Half of 4 is 2. So in here, 2. And then maybe we can do a split line across like this. So we've got 3 shapes. We get this here, which is 4 squares, 2 by 2. We've got 1, 2, 3, 4, 5, 6, 7. We've got 7 in here. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, 10 plus 2 is 12, plus 1 is 13, plus 4 is 17, plus 7 is 24. So the area of this is 24. So it's looking like shape 4 is the biggest area. Now these type of questions will take you a while because there's a bit of comparison that you have to do between all the shapes, and it's not obvious which one is bigger because you have to count them. Even though this is a long shape here, I thought that this shape here was going to be bigger just by what I predicted with the area. But it's 32 and this is 34, so this is bigger by 2 units. And be careful also with the question. It says which one has the largest area. Some of the questions also says which one has the smallest area, which one has the second biggest or second smallest area. So be careful of what type of area they are looking for. Okay. Now the next question is much easier because we're now just looking into the basics of that formula that we had. So we're going to calculate the area of this pool table. In other words, we're just seeing how many of these meter square units we can get within this 2D shape. And you got to remember the area for a rectangle is just length times width. Or in other words, 4.5 times 2. And 4.5 times 2, obviously you can get your calculator to get this out. We're just doubling 4.5. And this is 9 meters. Now you see that this is little 2 up the top. 9. So how you pronounce this? A lot of people say 9 meters squared. That's actually incorrect. The correct terminology is 9 squared meters. It's 9 squared meters. Because saying 9 meters squared, even though that's the order from left to right, we've coined this little 2 at the end of the square, which is a bit of a silly thing to do. But saying 9 meters squared is implying that you want to get 9 and you want to times it by itself to get 81, which isn't the case. We've already got the answer. It's 9 squared meters. So if you were to put how many squares there are 9 squared, and then the unit meters. So just be careful with your pronunciation of that. But the formula is pretty simple. Just like times width. Now, this one here, what is the correct area for the road sign for this question 8? You got to remember that the area is half times base times height. And when we say base times height, there are 2 different types of triangles that we can see. There is a right angle triangle, and there can sometimes be a scalene, isosceles type of triangle, equilateral triangle. But what's consistent between the 2 is at the bottom they will have a base, and then from the bottom to the top at exactly 90 degrees, or here at exactly 90 degrees, we know this is 90 degrees, this is called a height. And we need to be specific. It is a perpendicular height. Now it does sound fancy, perpendicular height. And the reason why we say perpendicular height is sometimes a question might give you the base, and then they'll give you this length here, where technically that's not the height of the triangle, that's the slant of the triangle. The proper height is going from the exactly 90 degrees to what the base is from the bottom to the top. So be very careful. You always have to make sure that you look for this height rather than the slant. If the slant's given to you and not the height, at a year 7 level anyways, this can't be solved to get the area. So let's have a look. We have 40 and 30 as a base and height respectively. And what we're doing is just half times base times height, which is just half times 40, which is our base, times 30. We can go ahead and use our trusty calculator to work this out. So we can go ahead and do half. So use the fraction button, 1/2. And there are different ways to calculate this. Half times 40 times 30, which gives us 600 squared centimeters. 600 squared centimeters. meters. Now another way you can work this out on the calculator, and it makes no difference whatsoever, if we just did 40 times 30, get our answer, 1200, and just press the divide by 2, this will also give us 600. So timesing it by half or dividing by 2 on the calculator will give you the same answer because it technically means the same thing. Then you'll get questions that look like this. If the area of the city block is 6,000 square meters, how long is the unknown side length? So we know that 100 times some sort of number that we don't know is going to give us 6,000. So we need to figure out what this number is, because remember our formula is length times width, and that will give us our area, but our area has already been given to us. So how we work this out is purely simple. We just get 6,000 and divide it by 100. 6,000 divided by 100 when using the calculator will give you 60, and to be specific, 60 meters. So this length here has to be 60 meters because 60 times 100 will give us our original area in the first place, which is 6,000 square meters. So my answer here is 60 meters. Now we've got a few more examples, two more. This one here, number 13, if the area of this triangular paddock shaded green is 1,400 square meters, calculate the unknown side length. Now this one is a bit different because we are using a different formula. We're using the area of a triangle is half times base times height. Now this is saying our height is 70. Now, we already know what our height is, and the area itself is given in the question 1,400. What we want to know is, what's the base length? What's the base length? Now, there are different ways that we can approach this, and there's obviously the algebraic way, which I'm not necessarily going to show you. I'm actually going to show you the logical way of solving this. Let's say that we know that this area from here to here is 1,400. We also then know that because a triangle is always half the amount of a rectangle, we also know that this area in here, this triangle, is also 1,400. It has to be because it's exactly the same area as this one here. It's just mirrored in the diagonal direction. So how about we get the area of this full rectangle, which we know is 1,400 plus 1,400, and this is equal to 2,800. Now you'll notice that the height is still the same, and the base length will still be the same. So we still know that this height length is 70, and this base length is unknown. So if 70 times some unknown number will give us the full area of this, which is 2,800. We can go ahead and use the skill from the previous question, 2,800 divided by 70, and then this will give us what that length is. So 2,800 divided by 70, and this will give us 40. So let's try this out. Let's put 40 into here. So remember, we'll do 70 times 40. So 70 times 40. This gives us 2,800, and then divided by 2, because we're dealing with a triangle, 1,400, which is the area in the first place. So a better way to approaching this is just putting that amount there, getting the double of that amount, and just working it out as normal, because the answer will still technically be the same, because you are using the same length and the same height. In this case, our missing side length is 40 meters. And last question to wrap this up, which shape has a perimeter of 14 meters and an area of 12 squared meters? Now remember, perimeter is just the outside length of a shape. And this is saying that a perimeter of 14 meters must be made, with the exception that the area is also 12 square meters. We'll look at the first one. If this is 4 meters, this will also be 4 meters. If this is 3 meters, this will also be 3 meters here. So 4 plus 3 is 7, plus 4 plus 3 is 7, 7 plus 7 is 14. Cool, that ticks off that criteria. Now let's see if the area is 12 square meters. This is a rectangle. 4 times 3 is 12. 12 square meters. Alright, this ticks it off. So this must be an answer. Now just to double check, make sure that we won't check every single one, or just make sure that this one is incorrect. 5 plus 2 is 7. So 7 plus 7 for the whole perimeter. So 5 plus 5 or 2 plus 2, same way. This is 14, yes. But then when we look for the area, 5 times 2 is 10 square meters. This can't be it. So again, you can check these two just to make sure, but we kind of already got there. We know that this is our answer. And remember, a lot of these questions from 16 onwards follow this format, making sure that you look for the perimeter and the area. And that concludes this video for this skill. Go ahead and attempt this one, an essential assessment, and I'll see you in the next video. Bye-bye.